In this video here, we're going to learn on how to sketch sine function in the form of fx equals to a sine bracket mx plus c plus k. But before we go on further for the graph sketching, I need to introduce to you the few terms that are important that we will use it as a reference later in graph sketching. But before that, let us try to observe what I mean by that we want to have the sine function in the form of a sine mx plus c plus k here. First of all, it's a sine function where the angle part here comes with linear expressions. And this linear expressions here is the only part that we have x. The rest of the part is come with constant. The a here is actually referred to the coefficient on our sine functions. The k here is just some arbitrary constant. So, for example, if let's say I have the basic k, fx equals to sine x, so the coefficient, the capital A, coefficient of the sine will be positive 1, coefficient of x is positive 1, constant c and k is 0. When the time I have sine 2x, so again, coefficient of sine is plus 1, coefficient of x now become plus 2, c and k still remain 0. Go further, if I have sine 2x minus pi over 4, so if I compare the difference between this one and the previous one, the second one, you see the difference is that with an additional value on the coefficient of c. Then the fourth one, negative sine x, you will see that compared with the first one, you see the difference is on the coefficient on the sine functions. And the last one, that we have all the k's come together, have the value of a m c k, which is not equal to 0. I have a positive 3, coefficient of sine, negative 2 for coefficient of x, and then constant pi over 3, c, plus 1 for k. And in here, there is also some important remark that you need to take notes. There are some terms that we're going to make use in our graph sketching or in our problem solving later. So, first, amplitude. Amplitude. How we get the amplitude of sine function and what is amplitude? Let's say this is the shape of the sine functions that you have. The amplitude will refer to the height from this peak point here until this red dotted line. This is what we have for the amplitude. And the length of this amplitude here is measured by we're having the coefficients of the sine functions here. We modulus it. Why? The reason we want to have it modulus, because this is a length, it always comes with positive answer. Next, for your informations, in our graph sketching later, I will always start with the cycle. In here, the diagram here, this is one cycle. We'll always have my cycle here, when the time in graph sketching, begin with the x value such that mx plus c equals 0. I will have the graph begin with solving x from these equations here, and then in general the domain of the case of sine function is infinity to infinity. It is defined for all x value in general, whereas the range will happens to be having this constant k plus or minus with our amplitude. Okay, for the domain and range maybe we shall see later in details in examples. Next, let's summarize the important terms that we need to take notes before we go on further on graph sketching. First, the phase shift. So the phase shift is actually referred to the mx plus c here. We make it equal 0 and we solve it. And this is the part that we find out the initial point of our cycle. Where if let's see we have the shape of graph like case 1 or like case 2, the position of the phase shift here will be the part that we have in the point here marked with a red cross. So this is the initial point where we start the cycle of the sine graph. The next important terms that we're going to discuss here is that what we call as the period. So how we find the periods is that we would like to have 2 pi divided with modulus of m, where the m here is referred to the coefficient of x. The modulus here is to ensure that I always have the positive result in this case here, where this is actually to determine the length of one cycle of our sine. So to have a better idea on what I mean by the length of one cycle of a sine graph, let us see from diagram. Let's say I may have the graph like here, case 1 or case 2. Both of this is the case of one cycle of sine graph. Depends how's the shape that we have later. And the length of this one cycle here, which is the period, is being measured as shown in the animations here. So these are the length of the one cycle graph, which is the periods. Next, the important terms that we need to take note also is that the subinterval width, where this subinterval width here, how we do the calculation is that we find by using the period divided by 4 to determine the common difference of x value that we're going to use in table for graph sketching later. So in terms of diagrams, again, we see case 1 and case 2. The subinterval width will be corresponding to what is shown by the diagrams here now. So these are the subinterval width that is important as a reference for us to do graph sketching later. Then next, we will construct the table, where the table will begin with the phase shift x equals to negative c over m based on the calculation, taking mx plus c equals 0, followed by 4 consecutive x terms with the common difference as we calculate from just now, period divided by 4, and then we complete the corresponding function value in the table. And lastly, we go for graph by beginning with sketching one cycle graph based on the table, and then we extend or reduce the graph according to the domain. So this is the introductions that we have for the case of graph sketching for sine functions.